All right, hello AP Calculus. This is section 3.7, related rates. This is a section that is primarily word problems, except for the first one, where you're going to have to read a word problem, apply, I'm going to say, a popular formula within our mathematics domain, and use some derivatives to come up with some results. Okay. Now, the interesting thing about our work is that each of our variables will be influenced by a common, I'll say, kind of exterior or outer variable, okay, like time. Time will have an influence on all of your variables in a different way. And what we're going to have to do is figure out a missing piece amongst our formula. Okay, so let's take a look at this first one. It says for y is equal to x cubed plus x plus 2, find dy dt when x equals 3 and dx dt is equal to 4. Okay, and what they're suggesting is that time is a factor with respect to both x and y. And when we take a derivative of each of our variables, we're going to do it with respect to time. Okay, so derivative of y is 1. So this is 1 dy dt. The derivative of x cubed is 3x squared. Dx dt, I'm going to use x here. And the derivative of x is 1 dx dt. And derivative 2 goes away. So, and then after you do that, we're going to find and solve for dy dt, which is that guy. Now your x is 3. Your dx dt is 4. And your dx dt is still 4. All right, your dy dt is still on this left side. And I'm just going to do this math here. 3 times 3 squared, that's 9 times 3 times 4. That's 108. Plus 4 is 112. And we are done. So, but this is just a fundamental representation of showing how you're going to take your variables and derive them with respect to another variable, which in this case was time, as you'll find that will be with most cases. If you wanted, had you stopped right here where I started that, okay, you could actually do that on your AP test if it was free response. You could just leave it at that spot. All right, I love Krispy Kreme donuts. My favorite place in the world is their factory, where they have that like film of hot glaze just kind of dripping over the donuts. And I would love to take like a shower cap and maybe some goggles and put it on and then lay on my back on the conveyor belt and just like open my mouth as the hot, like gooey glaze just drips in my mouth. So anyways, as the hot liquid frost from the Krispy Kreme donut factory drips to the floor, a puddle is formed, what a waste, in the shape of a circle. Okay, so it's like some puddles going, and it's getting bigger and bigger and bigger and bigger and bigger and bigger as time goes on. Where the area increases at the rate, so here we go, area increases at a rate of 3 inches squared per second. Find the rate at which the radius is increasing when the diameter is a ½ foot long. Okay, so here's what I got. Circles have 2 formulas. It's either pi r squared or its circumference. And since I'm not really looking at the distance around a circle, it's the area, what I'm going to do is use the area formula with respect to time. Okay, so it looks just like the regular formula that I have up here. It's pi r squared. However, I'm just going to say it's a function of r of t, time, and so is the area. Both the area and the rate are representative of some time, and they change as time changes. Okay. And once I set this up, I'll take a derivative. So the derivative of a of t is dA dt. I'm going to call that a prime, that's fine. And the derivative of this guy on the right, be careful, 2 times pi is 2 pi. R of t, it's really to the first. I don't want to write a first here because it looks like a prime sign. Okay, and then r prime of t. Okay, or you could call that dr dt. And I'm just going to write it like this because that's the way I started it. Okay. Okay, now let's be careful as we plug things in here. It says the area increases at a rate. When you see the word rates, okay, that's the red flag. Boom, red flag that says that this is either a dAdt or a drdt, but it's a d something. Okay, so rate means derivative. So the rate at which the area increases. Okay, so I'm going to put that in here. 3 inches squared per second. Okay, equals 2 pi. Now, I have two things left, and one of these is going to be related to what I wrote over here. Now, the fact that it says find the rate, okay, suggests that this is what I'm solving for. Okay, so what I'm going to do is find what this RT is, and then I'm set. Okay, so remember R stands for radius. And my radius has to be in inches. So now they don't give me a radius, they give me a diameter is a 1/2 foot. Okay, so that means my diameter is 6 inches, which means my radius is 3 inches. Okay, and that's what's going to go in here. All right, so my last step is just to solve for what they're asking for, which is the rate at which the radius is increasing. And I'm going to divide by basically this 2 times pi times 3. So I got 3 inches per second. This is squared per second. My dr dt will be here. And remember that this was 3 inches inside, so that is 2 pi times 3 inches on the bottom. And you may recognize that the one of the set of inches will go away, and so will the 3. So you're left with 1 inch per second over 2 pi. Okay, and if you want, you can divide that out, but you don't have to. Okay, you can just kind of leave that as is. Cool. All right. If you were to divide this out, make sure you go to 3 place values past the decimal and then stop. Don't cut it off at 2. Go at least 3. All right, last one. This is a true story. Because Mr. Rothery is such a good guy, Santa decides to visit his house each Christmas Eve. Since Santa's house is considerably old, Santa parks his reindeer on the ground and then uses a 25-foot ladder to climb to the roof and down the chimney. As Santa drops off Mr. Rothery's gifts, notice it's not singular, it's plural there. Probably doesn't surprise you. He notices a 24-inch party pizza left as a gift for Santa to eat instead of cookies, and he decides to eat the entire pie. Santa then climbs back up the chimney and begins to walk down the ladder. Due to the extra belly weight from the pizza, the ladder slides away from the house as Santa begins his descent. The ladder begins to move away from the house at 2 feet per second. How fast is the ladder moving down the house when the ladder is 15 feet from the house? So let me see if I can draw a picture here. And where's this guy? Let's just pretend this is the side of my house. And that's pretty good. Oh, sorry. Okay. And this is the ladder. It's 25 feet. And let's see. It says, how fast is a ladder moving down? Okay, so this guy is sliding down. And if that's sliding down, this is sliding out. When the ladder is 15 feet from the house. Okay, so that means this guy is 15. And they want to know how fast. They want to know the rates. That's what we're finding. Okay. And I think they said one more thing. Here it says, the ladder begins to move away from the house at 2 feet per second. So 2 feet per second. Now, something to consider. This is It's going to surprise you, but just because this moves at 2 feet per second doesn't mean it moves down 2 feet per second. That's a huge misunderstanding. The rate isn't universal to all three sides. Okay, so keep that in mind. All right, now notice this is a right triangle, and there's a lot of formulas with right triangles, especially trigonometry, but because I'm dealing with sides, what that means is I can use Pythagorean theorem. Okay, so what I'm going to say is that this side is A, this side is S, this side is U, and so A of t squared, okay, t, there we go, A of t squared, plus S of t squared is equal to U of t. Let me get that. U of t squared. Okay, it's Pythagorean theorem, you're dealing with sides. It could be that it's a trigonometry one if they're talking about angles, okay, and you use sine or cosine or maybe tangents, okay. There's a lot of different formulas that could be used. Okay, now take the derivative. 2 a of t times dA dt plus 2 s of t times ds dt equals 2u of t times du dt. Okay, now if you want, you can divide everything by 2. We'll do that in our next step. But let's start thinking about what some of these things mean. Okay, now I know what the distance of a of t is, that's 15. And I know the rate for it, it's 2. Okay, so that part's all done. I'll leave the 2 there, who cares? Okay. Now the s of t, I don't know what that is, but I need to also be able to find ds dt. Okay, so that's what I'm solving for. ds dt, and the s of t, well, geez, if this side is 15 and this side is 25, how do I find this last side? Well, maybe Pythagorean theorem. So let's see, a squared plus s squared equals u squared. A is 15. S I don't know. U is 25. U squared is 25 squared, so that's 625. 15 squared is 225. That's an S, not a 5. And if you subtract that over, that leaves you with 400. And that means your S is 20. Now, some of you may already have known that because this is a triple, or a form of a triple. It's a form of a 3, 4, 5. That goes here. And U is this last side. It is 25. And this is going to sound crazy, but it's going to make this look so nice. My du dt is how fast this changes. Now, here's the thing. This is a 25-foot ladder that's always going to stay 25 feet. It's not going to condense as it's being moved or spread out. It says it's a 25-foot ladder, and it's locked that way. So what is the rate at which it changes? It doesn't change. Okay, so in this case, the udt is 0. Okay, so there's my 0. I forgot my rates. I'm sorry. This is feet. Okay, so if I multiply these, 2 times 15 is 30, and that's 60 feet squared, I believe, per second. And this is plus 40 feet ds dt. Okay, and I gotta solve for this ds dt, so I'm gonna move that 60 to the other side. And that's negative 60 feet per second. Okay, and I forgot this 40 has the ds dt with it, sorry. Okay. And then you're gonna divide to get this ds dt by itself. and you're going to divide by 40 feet. Okay, and then what does that leave me with? Well, the change of the s with respect to time, which is what we're looking for. 60 divided by 40 is -1.5. And let's see, this was actually feet squared. One of these feet will cancel with one of those, and so you'll be left with feet per second. And that is your final answer. What does this negative mean? It means you are you're dropping, okay, at this rate, 1.5 feet per second. Okay, now you want to be careful. You don't want to say you're dropping a -1 feet per second. That's a double negative there, which means it would be a positive. You just want to say you're dropping 1 feet per second, or the change is a -1.5 feet per second. Okay. All right, there are certainly an infinite amount of ways that you can do related rates. And so every question has its own problem. Tomorrow in class, I'll try to give you some examples, which means I probably did that today in class, depending on when you're watching it, just to give you some ideas of what's going on. But it takes a lot of independent thinking to come up with the formula, but once you got it, then you're set. Okay? All right, I hope you're having a good day. We will talk to you soon.